So in our question we were told to find the the equation of the Earth's orbit. What did they give us? They gave us the mean distance to be 93 million miles and the perihelion to be 91.5 million miles. So what can you do when you are given this scenario? The best thing is to draw. So we'll draw what we have, we'll draw it, and we'll say that to the center we have this mean distance. So this distance here, that's the mean distance, which was what? Which was 93. So we'll just get 93. And they told us that the perihelion is 91.5 million. So you need to acknowledge to say if the sun is here, the distance from the center of the sun to the nearest vertex, that's perihelion. So this is 91.5. Now for us to plot the equation, we need to find it has to be a squared plus b squared equal to 1, or vice versa. Maybe a can be under y and b can be under x squared. Yeah. So but our main goal is just to find a and b. So for a squared it's simple because we know that the mean distance is equal to what? A. So mean distance is equal to a. So meaning 93 squared, that would be what? That would be our a squared. So now our problem now only comes for us on how we're going to find what? B. So if you have a and you have been given the perihelion, we need to find b. How do we find b? Because we know that the distance from b is here. We know that from the center to that point there, it's b. So now how do we find it? How do we find b? We can acknowledge that we know that for the ellipse, c squared is equals to a squared. C squared is equals to a squared minus b squared. So now do we have c? We don't. But can we find c? Can we find c? That's the question. So now if you look at this, we know that the distance for c is this boy here. This is c. So we have been given the distance to say, we've been given the mid distance. The mid distance is from the center to this vertex, or from the center to this vertex. So we know that the total distance here, we've been given the total distance for this body here. And we have been also given what? Been given this distance. This one here, which is what? The 91.5. So how can we find this distance here? We can just go ahead and say C is equivalent to what? C is equivalent to mean distance less or subtracting perihelion. Then after finding C, what are we going to do? After we find C, we are going to say b squared is equal to what? A squared minus c squared. So there are many other ways on which you can find c. In other scenarios, they won't give you the what? They won't give you perihelion. They are going to give you what? Epi. So perihelion, it starts from the sun here going to this the farmost vertex. So now if you are given perihelion and mid distance, you're just going to subtract, and if you're given aphelion and mid distance, you're just going to say aphelion less mid distance. You're going to find the distance in here. So that's the way you are going to go about it. So for this one, it is 93 minus 91.5. 93 minus 91.5. So we're having 93 minus 91.5. So our answer is 1.5. So this is our C. This is our C. So now B squared, or let me just say B is equal to root of, now what is our mid distance, which is A squared, 93. So we have to B squared less 1.5, which is C squared. So 93 squared less 1.5 squared, we're having 8,646.75. Now what's the square root of that boy? The square root of this boy, we're getting 92.79. So now this is our B. This is our B. So we'll come to our equation. In our equation, we need what? A squared, of which we have, and B squared. So since now we have B, how can we find B squared? We can just come ahead and square this here and square this here. So B squared will equal to what? 92.9879 squared. So let's just go ahead and square it. So B squared is equal to 8,646.75. So now, since we have B squared, and we have what? X squared. So X squared is 93 squared, then plus Y squared over, what was our B? This was our B. This was our 64 6.75. This is all equal to 1. So ladies and gentlemen, we have found the equation of the Earth's orbit. It's more like they just told you to find the equation of the ellipse. So from here, we are done. We are done with the application for ellipses. So now, where are we heading to next? So I'll send some questions for you to be practicing on as well, as we are starting parabolas. So we're going to start parabolas. Then from there we will be done with this topic. So what will just remain is for you now to be going through the questions, sending questions and asking where you are not clear. So start parabolas and we'll solve 2 questions, then we'll be done with conic sections.